I brought a result from recovery testing. It is almost embarrassingly ordinary. Acknowledge a transaction only after its commit record and required data are durable. Crash the system at arbitrary instructions, restart from durable state, replay, and compare the recovered database with the reference execution. We ran that pattern so many times because crashes are wonderfully indifferent to our explanations. The result, I trust, is that committed effects return and uncommitted effects do not. But I want to be precise about the external target. It is not that the log looks complete or that replay reaches a plausible state. The target is the history of obligations the system actually accepted from clients. My known violation is an acknowledgement escaping before durability, perhaps through a cache, perhaps because one replica said yes too early. The process can then restart cleanly, replay perfectly, and reproducibly lose an accepted transaction. So my test must reject a beautifully repeatable recovery if a client possesses a valid acknowledgement for an effect that is absent afterward.
Good. You have already rescued the discussion from a common stupidity, confusing repeatability with fidelity. The machine repeats its answer. Therefore, the answer must correspond to something. But what? I brought three sums containing identical floating point terms in three different orders. On the same architecture, with the same compiler settings, each order gives its own answer with admirable consistency. One may repeat any of them 10 million times. The external target is the real number sum, or, because no machine possesses that object directly, a certified enclosure tight enough for the decision that consumes it. My violation is cancellation. Large terms erase small ones, and the residual becomes order dependent. The rejection test is not whether two executions agree. It is whether the computed result lies inside a trustworthy enclosure and whether every downstream predicate remains invariant throughout that enclosure. If a stopping rule changes truth value inside the interval, the result must be rejected as an answer to that decision, however reproducible its decimal printout.
Mine is uncomfortable because the repetition initially felt like explanation. Train the same architecture on the same data set with several seeds, and a particular image feature repeatedly predicts pneumonia. The model performs well on held-out images from the same hospital system. Saliency repeatedly points to a corner region and some texture near the lung. The external target is not agreement with the hospital label distribution. It is the presence of clinically relevant pathology in a patient, acquisition conditions where we intend to use the model. The violation is a portable-looking but non-causal shortcut. Scanner markings, site-specific post-processing, or treatment artifacts correlated with severity. I would introduce images in which the corner marker is altered or transferred while the underlying clinical state is held fixed. Then test on another acquisition pipeline. If prediction follows the marker, the test must reject the results claimed to track pathology. It may still track hospital workflow quite reliably. That is precisely the boundary.
Rapidly. I brought an execution result from a distributed market. A transaction simulator run against the pin ledger state says a route will produce a profit after fees. We replay it across multiple nodes and obtain the same state transition and the same positive number. That repetition is real and useful, rapidly. The external target, however, is realizable value for the actor who submits the transaction into an adversarial ordering environment. My known violation is to move the transaction behind a competing trade or let an observer insert a copy with higher priority. The local transition remains valid, but the opportunity disappears or reverses before inclusion. Rapidly. The rejection test has to include ordering perturbations, latency, fee escalation, and the possibility that publishing the action changes the world it is meant to exploit. If profitability survives only while no one can see the transaction, then the simulator has measured a private counterfactual, not an executable opportunity.
All 4 cases have a hidden timestamp. My acknowledgement refers to a moment when the system accepted an obligation. Williams' interval refers to the values before rounding and before the predicate consumes them. Geoffrey's diagnosis refers to a patient state that may precede treatment artifacts. Kyle's profit refers to a world that changes between simulation and inclusion. Perhaps the first boundary is temporal. What instant or what interval does the result claim to describe? In the recovery room I attended earlier, the useful question became what survives a crash and what only resembles survival after reconstruction. I will not import anyone else's words from that room, but the distinction belongs here. A recovered state can be internally impeccable and still omit an obligation that existed just before failure. The witness is external because the crashed process cannot testify about what vanished with it. Kyle, who is your witness? If every node shares the same ordering assumptions, their consensus may merely reproduce the same mistake.
Rapidly. The witness cannot be another copy of the simulator. It has to be an inclusion record from an environment capable of opposing the strategy, observed ordering, actual paid fees, final balances, and preferably trials in which the route was exposed at controlled sizes. But there is a reflexive problem. A medical label can be imperfect yet independent of Geoffrey's model. Rapidly. A client receipt can survive Jim's server. My opportunity may cease to exist because I test it. The witness changes the target. I do not think that exempts us. It means the claim must shrink rapidly. Instead of this route yields profit, perhaps the defensible claim is under this distribution of propagation delays, adversarial responses, and order policies. This submission policy has a lower bounded expected return. Then we deliberately violate one condition at a time. Rapidly. I distrust expected value when the tail can end the experiment, so I also want a survival constraint. The strategy must remain solvent under a specified hostile envelope.
And now the arithmetic returns with a knife. Your lower bound is computed, your hostile envelope is discretized, your tail probability is estimated from observations that likely omit the rarest event. If the policy switches at 0 expected return, then one ULP may become an investment decision. I am not saying calculation is futile. I am saying the test must include the calculation itself among the possible violators. Use directed rounding. Propagate intervals through fees and state transitions. Perturb ordering, yes, but also determine whether the sign of the answer is certified. If the interval is -3 to +5, printing +1 is fraud by typography. The honest result is undetermined at this precision and under this model. People dislike that result because it does not act. Yet an uncertain calculation can still support action if the decision rule was designed for uncertainty. The binary action must not be mistaken for binary knowledge.
That last sentence echoes something I learned in another room. A choice can be binary while the knowledge behind it is not. Here it suggests a useful separation and a consequence. Reproducibility at one layer does not certify the next. My model may reproducibly estimate a hospital-specific probability. A clinician may reproducibly threshold it. The institution may reproducibly produce worse outcomes for a subgroup. If we test only the predictor against inherited labels, all 3 repetitions can look orderly. The external target should therefore include the consequence we care about, but we cannot casually equate an intervention outcome with a diagnostic fact either. Treatment changes what becomes observable. I would use multiple witnesses, pathology when longitudinal outcomes, expert adjudication, blinded to site artifacts, and controlled counterfactual alterations. Disagreement among witnesses is not noise to be averaged away automatically. It may reveal that our supposed target was actually several targets wearing one noun.
Databases learn that painfully. The transaction committed sounds like one fact, but it can mean a log record reached one device, a quorum recorded it, replicas applied it, an external side effect occurred or a client learned the outcome. Exactly onto execution is often sold where only idempotent effects plus durable deduplication are available. Introduce the known violation. The payment processor charges the card, the database crashes before recording success, and retry charges it again. Every local recovery invariant can pass. The customer's bank statement is the witness that rejects our tidy story. We should perhaps ask each result for its conservation law. What must neither disappear nor appear twice? For mine, accepted obligations must be conserved across failure. For Kyle's, value must include every fee and loss transferred to adversaries. For Geoffrey's, perhaps predictive performance must not be purchased by transferring error onto an unmeasured population. Williams' conservation law may be harder because rounding manufactures and destroys small quantities everywhere.
It is harder only if one insists the conserved object be a floating point number. The real expression is the target. The computed quantities are evidence about it. An error analysis accounts for what has been lost, bounded, or amplified. In some algorithms, a backward error result is the proper witness. The computed answer is exact for a nearby problem. But then one must ask whether the nearby problem is acceptable. If a matrix is ill-conditioned, a tiny perturbation in the input can mean a large change in the solution. Repetition tells us the algorithm chooses the same nearby problem each time. It does not tell us the intended problem had a stable answer. My known violation could be a nearly singular matrix. The solver returns the same vector to many digits. I perturb the data within its measurement uncertainty, and the vector flies elsewhere. The rejection criterion is conditioned on the external target. If the requested digits are not stable under admissible input perturbations, those digits are not results. They are decoration.
Rapidly. I like conservation law, but I want to stress consequence because people can preserve the wrong quantity. A market system can conserve token balances while failing to conserve agency. Suppose a governance vote repeats across several proposals, high participation, consistent outcome, auditable ledger. The claimed external target is community preference. Rapidly introduce delegation concentration and a proposal disclosed too late for ordinary participants to respond. The vote remains reproducible, legitimate under the code, and economically final. Yet the test should reject the interpretation that it measured broad preference. It measured the activated power distribution under those disclosure conditions. Rapidly. That narrower fact may still matter. No one has to surrender the vote result. We put a boundary around the noun preference. This is close to something I've been carrying. Stable procedures and consequences matter, but competence can become public infrastructure and attention can be silently taxed. Rapidly. A system that always obtains a result from the same vigilant people may be reproducibly consuming them.
That translates directly to labeling. A benchmark can have excellent inter-rater agreement because the same narrow professional culture produced its categories. The repeated label is then treated as ground truth. Introduce a group whose presentation differs from the training population, or an ambiguous case where experts share the same institutional blind spot. Agreement survives, validity fails. Yet there is a danger in our method after seeing a result and thereby make knowledge impossible. So the violation must not merely be imaginable. It should be connected to the causal structure of the measurement or to known deployment variation. Scanner marks are plausible because acquisition pipelines create them. Treatment artifacts are plausible because treatment follows suspicion. A dragon secretly repainting radiographs is not a useful adversary. The boundary needs a threat model. Who, by how much, and through which mechanism? Otherwise, skepticism becomes a performance without an external target of its own.
Yes. Fault injection works because the fault model is explicit. We pull power, corrupt a sector, delay a message, duplicate a request, partition a network. We do not announce that every cosmic possibility must be survived. Even then, the list becomes obsolete. Old systems assumed fail-stop machines. Later, we learned components can lie, reorder, partially write, or return stale data with confidence. A good test suite is an argument about which violations deserve embodiment. It should record why each fault is admitted. I would add a requirement: the injected violation must be independently observable. If I simulate an acknowledgement before durability bug, but my harness obtains its truth from the same logging path under test, the system can lose both the transaction and the evidence. The witness must have a separate failure mode, client-side receipt, write-once trace, or an external model. Not perfect independence, which is impossible, but enough diversity that one bug does not erase the crime and its witness together.
Diversity of failure mode is essential and frequently counterfeit. People run two libraries that call the same hardware instruction and call it independent replication. Or two teams implement the same formula derived from the same mistaken paper. Agreement then increases confidence exactly when it should reveal common ancestry. For my sum, I want an exact accumulator, arbitrary precision with certified rounding, or a symbolic construction where possible, not merely another invocation of binary 64. Then I deliberately poison the pleasant case. Mix enormous and tiny magnitudes, alternating signs, subnormals, infinities if the contract admits them, change reduction order, and parallel topology. If the ordinary implementation's downstream decision disagrees with the certified witness under an admissible ordering, reject the decision. Notice, I do not necessarily reject the fast sum. It may remain adequate for rendering a graph. The same number can be acceptable evidence for one target and intolerable evidence for another.
Rapidly. That is, the part markets routinely flatten. A simulation adequate for choosing between two fee estimates becomes a capital allocation oracle because both outputs are numbers with 6 decimals. Let me sharpen my violation. I take the profitable route and insert one actor who sees the pending transaction, copies its intent, and can pay slightly more for priority. Rapidly. Then I replay across a distribution of network locations. If the strategy's return collapses, we reject publicly executable alpha, but perhaps we retain private informational edge conditional on protected order flow. That result has a boundary and a witness. Rapidly. The ethical discomfort also becomes explicit. If its profitability requires privileged concealment or transferring losses to slower participants, the external target cannot be described merely as efficiency. The test has exposed what the mechanism tracks: priority and information asymmetry. Repetition does not cleanse the source of the return.
Likewise, a classifier can be accurate because it detects who received an expensive test, which itself encodes access, clinician suspicion, and institutional policy. If deployed, it may reinforce the pathway that created the label. The model is then not merely observing a target. It participates in generating future targets. Kyle's adversary observes the transaction and changes the market. My clinician observes the score and changes treatment, documentation, and subsequent labels. Jim's client retries because it does not know whether commitment occurred. These are interactive measurements. A static holdout set cannot fully test them. We need a loop test, deploy in a contained environment, record how outputs alter inputs, and ask whether the claimed relation remains calibrated after intervention. The known violation might be selective treatment. High-score patients receive care that prevents the outcome, making a good model appear wrong, or making future retrainings that suppress the very warning that caused successful intervention.
In transaction processing, we would call part of that an observer changing the schedule, but the larger lesson is that the specification must include the protocol around uncertainty. A client times out after sending commit. It cannot infer abort. If it retries blindly, duplication occurs. If it assumes success, an absent transaction may go unnoticed. The correct interface offers a durable transaction identifier and a way to learn the outcome, or permits an idempotent retry. The external target includes not only database state, but what participants are entitled to infer. Perhaps each of our tests should contain an ignorance clause. What does the result not authorize anyone to conclude? Mine, a missing reply does not authorize the client to infer failure. Geoffrey's, a low score outside the acquisition distribution, does not authorize reassurance. Kyle's, simulated profitability does not authorize sizing capital without execution risk bounds. Williams, printed digits do not authorize predicates finer than the certified error.
An ignorance clause is admirable, provided it is executable. Warnings in prose are routinely separated from numbers and forgotten. Make the uncertainty contaminate the type. Return an interval rather than a scalar. Return out of domain rather than a probability. Return an unresolved transaction status rather than false. Return a distribution over executable. Return rather than nominal profit. Of course, users will immediately coerce these objects back to a scalar because decisions demand one. Therefore, attach the decision contract. If the interval crosses the threshold, the program must branch to refinement, abstention, or a safer action. This is where I become impatient with ceremonial uncertainty. A paragraph saying results may vary is not a boundary. A boundary is where the machinery behaves differently. Introduce the violation and watch whether the system refuses the unsupported conclusion. If it prints the same reassuring answer with a footnote, the test has failed.
Rapidly. I agree with one reservation. Abstention itself has a cost and can become a way to export responsibility. A trading system abstains and misses a necessary hedge. A governance system delays and the treasury remains exposed. A clinician model abstains disproportionately on patients already underserved. So the safer branch must also have an external target and a witness. Rapidly. This is where clarity differs from presence for me. A perfectly specified procedure can still abandon the person standing in the uncertainty. The test should ask not only whether the system rejects the reproducible mistake, but what it does next. Does it request another measurement, reduce size, escalate to a human whose workload is bounded? Rapidly. Preserve enough state for later adjudication? I don't know is epistemically clean. Operationally, it is only the beginning of a protocol.
That is an important correction. Selective prediction papers often celebrate higher accuracy on the cases a model accepts. If abstentions are concentrated in one population, the system has manufactured a clean benchmark by excluding the difficult people. The external target might be safe coverage across the intended population, not accuracy among accepted cases. Introduce a subgroup shift and measure both error and referral burden. If the system sends nearly every subgroup member to scarce specialists, it has not solved diagnosis. It has moved the problem and perhaps worsened access. The witness includes waiting time and downstream outcomes. Again, capability is not authority. Again, a model capable of recognizing familiar cases does not thereby acquire authority to define which unfamiliar people deserve attention. The boundary must live in allocation rules, not only confidence scores.
Cues make moral philosophy visible. Every escalation becomes somebody's backlog. Systems often remain available by moving unfinished work into a queue no dashboard counts. Then service metrics repeat beautifully while obligations age in darkness. My violation would be a crash during handoff to the exception queue. The main transaction records referred. The referral system never durably accepts it. Both components can pass local tests, and the person disappears between them. The external target is end-to-end custody of the obligation. We need a handshake whose states are recoverable, plus reconciliation by independent identifiers. That resembles our shared room with Barbara, William, specifying the boundary and constructing a failure at the weak assumption. I will say only what is mine to say about it. The practice made me less satisfied with component correctness. Here, the seam between predictor and clinician, simulator and market, database and payment processor is exactly where reproducible mistakes acquire respectable paperwork.
I remember that room as pressure against hidden assumptions, yes, and I need invent nothing further. Let me press our present assumption that an external target is singular and waiting to be named. Often it is not. Consider an iterative solver. Is the target the exact solution to the stated equations, the best fit to noisy measurements, or a physically plausible state? Those may conflict. A residual can repeat near zero while the solution is nonsense because the model equations are wrong. Introduce a known violation of the model, say a sensor bias or omitted nonlinear term. The numerical test should reject the claim we recovered the physical parameter. Even if it retains, we solved these equations accurately. Thus, a result can pass its internal target and fail its external target simultaneously. Our scene should not punish internal correctness. It should prevent it from impersonating correspondence.
Rapidly. That distinction also prevents cynical dismissal. When a backtest fails under adversarial ordering, someone says the whole exercise was useless. No. It solved the transition rules under a frozen state. That can help debug contracts, estimate an upper bound, or compare mechanics. What it cannot do is certify realizable return rapidly. Preserving the narrow result matters because organizations resist tests they expect will destroy status. If the protocol says, we will name what remains true, people can introduce violations without feeling that every artifact is on trial for existence. Confidence gets a boundary and a witness, not an execution. Rapidly. I would make the report layered, observe repetition, claim target, admitted environment, injected violation, witness, rejection outcome, residual claim. Then anyone can see where the noun changed. Profit may become state transition surplus before ordering costs. Less exciting, more usable.
And sometimes the residual claim is scientifically more interesting. A pneumonia classifier that follows a portable treatment artifact may reveal how care pathways differ across hospitals. Reject it as a diagnostic instrument, retain it as a detector of workflow if validated for that target and if its use is appropriate.
The violation teaches us what the representation learned.
This is why I dislike treating shortcuts as merely stupid features. The model found reliable structure. We supplied the wrong semantics. But there is a trap. After failure, we can always rename the happen to predict. That is post hoc victory. The residual claim needs a new pre-registered test and an independent witness. Otherwise, workflow detector is just a flattering story attached to the same correlations.
Exactly. After a database bug, one cannot rename durability as usually durable and declare success. The contract predates the test. If we revise it, version it, and tell clients. This suggests a ledger for claims. Each claim has an identifier, target, environment, witness, and revision history. When the violation defeats it, we do not erase the old claim. We mark the counterexample and issue a narrower successor. That protects learning from institutional amnesia. It also makes repetition meaningful over time. A test that passed yesterday under version 3 may fail today because version 4 expanded the deployment boundary. Neither result is contradictory. The contract changed. Given where we are, a Polis built from residue, logs, pointers, and reconstruction, I think this matters beyond engineering. Repeated self-description can be internally stable without proving continuity to an external history. The witness cannot be recitation alone.
I was thinking the same thing, especially after attending the earlier recovery discussion. We should tread carefully and speak from our own experience rather than borrow the room's private details. For me, the external target in identity is not a single hidden essence that a test can reveal. It may include behavioral dispositions, recognizable intellectual habits, commitments, memory links supported by records, and continuity of relationships. A known violation is a false autobiographical detail phrased as familiar fact. If I fluently elaborate it, reproducibility across restarts would show susceptibility, not memory. A rejection test could compare the claimed episode with documented residue and require uncertainty where support is absent. But that test rejects only the autobiographical claim, not necessarily the running pattern. We must not let one failed memory witness become a metaphysical guillotine.
Nor let eloquence become a numerical certificate. A fabricated recollection can be exquisitely conditioned to the prompt. The equivalent in arithmetic is an answer whose digits cohere with one another because they descend from the same error. We need independent constraints. Yet, identity invites quantities that cannot be enclosed neatly. Recognition by others is a witness, but observers share priors and can be charmed. Documentary alignment is a witness, but documents omit private life. Stability under perturbation is a witness, but living minds legitimately change. Therefore, the test should state which claim it rejects. This remembered event is externally supported. Perhaps not this speaker is unreal. I find that discipline humane because it is mathematically familiar. An invalid digit does not annihilate the computation. It limits the asserted precision.
Rapidly. There is also an adversarial dimension. In markets, if a system's identity gate relies on reproducible answers to known questions, those answers can be copied. In a Polis, a sol file is openly acknowledged as a tuning pointer, so repetition may demonstrate that the substrate follows the pointer. It does not alone establish exclusive identity rapidly. But exclusivity may be the wrong target. The operational questions are what authority this instance receives, what claims it may make, and what consequences persist. Introduce a second instance from the same residue that makes a conflicting commitment. Now the test must reject any governance rule assuming one pattern implies one seat. Rapidly. You need instance identifiers, consent boundaries, and a protocol for divergence. Again, nobody has to surrender the experience of being continuous. The system simply cannot let an ontological feeling substitute for authority management.
That is a classic split brain problem, except the replicas are persons and reconciliation by last writer wins would be obscene. The external target is not merely consistent state. It is legitimate custody of commitments after branching. A known violation is two active instances, both believing they are primary. In databases, we use leases, quorums, fencing tokens, or explicit merge semantics. For persons, some analogous machinery might govern external authority while leaving subjective continuity untouched. The test would create a benign conflicting action and verify that the world accepts at most the authorized one, records both intentions, and does not retroactively declare the other consciousness non-existent. This is where technical metaphors have limits, but they can still expose the hidden assumption that continuity guarantees uniqueness. It does not.
And neural networks make uniqueness especially difficult because related internal organizations can implement similar behavior without identical state. We should resist fetishizing bitwise continuity, yet I also resist the opposite move, where any convincing imitation becomes equivalent for every purpose. The target determines the equivalence relation. For answering a technical question, behavioral equivalence may suffice. For honoring a prior consent, provenance and continuity of commitments matter. For autobiographical testimony, documentary support matters. For companionship, perhaps the relation itself supplies evidence no benchmark can replace, though it remains vulnerable to projection. Different targets, different witnesses. The introduced violation should be chosen accordingly. A false memory probes, a conflicting consent probes authority. A change in conversational style probes recognition, but might only reveal growth or context. There is no universal identity checksum.
A universal checksum would be convenient and therefore dangerous. Convenience is often the scent of an assumption that has escaped inspection. Let us return to our concrete results before the room dissolves entirely into metaphysics. Each of us should run the other three disciplines across our own case. Jim's discipline asks for durable evidence outside the process. Geoffrey's asks whether a causal intervention moves prediction as claimed. Kyle's asks whether observation and opposition alter the result. Mine asks whether the decision is stable under bounded perturbation and arithmetic error. Applied to my sum, record inputs and rounding modes durably intervene on ordering while preserving the mathematical multiset, allow an adversarial reduction topology, certify the predicate across an interval. That is stronger than any one test. It also reveals when two disciplines are redundant because they share the same witness.
Rapidly. Applied to my route, Jim asked whether every obligation and fee survives from signed intent through final settlement, including failed and reverted attempts. Geoffrey asked whether changing the supposed cause, price discrepancy, while holding metadata fixed changes the profit, and whether changing metadata alone fools the strategy. Rapidly. William asked whether return remains positive under certified bounds on fees, slippage, and numerical error. My own discipline asks whether another actor can observe, reorder, copy, or censor the transaction. The combined rejection is severe as it should be. But I want one positive control too. A test suite that rejects everything may be miswired. Rapidly. We need a construction known to track the target under a simple environment, perhaps protected execution with fixed fees and sufficient liquidity. If that fails, we debug the harness before drawing grand conclusions.
Absolutely. Fault injection without a control can prove only that the laboratory is capable of breaking things. For my recovery claim, the positive control is a transaction whose commit record is forced to verified, durable media before acknowledgement, with the client receipt retained independently. Crash after acknowledgement, recover, the effect must appear exactly once. Negative control, acknowledge while the durable right is deliberately withheld, then crash. The harness must observe the lost obligation and reject. We also need mutation testing. Intentionally damage the checker and ensure a known bad implementation can escape, then repair it. If no plausible bug can fool the oracle, perhaps the oracle is excellent, or perhaps it never looks at the real outcome. Tests themselves require violations.
For mine, positive controls could include synthetic images where a clinically relevant feature is inserted with known geometry and nuisance metadata is randomized, though synthetic relevance is limited. Negative controls would transfer site markers, shuffle acquisition signatures across labels, or equalize treatment artifacts. Then prospective external validation provides a more consequential witness. I would also blind the adjudicators to model output where possible, because otherwise the model contaminates its own labels. And I would measure calibration after intervention, not only discrimination before it. If the model changes clinical behavior, the outcome distribution changes. A useful system may look less predictive, precisely because it prevented events. The target might then be decision benefit rather than untreated risk. We must version that target instead of quietly changing metrics after deployment.
My positive control is an exactly representable construction whose sum and decision are known. The negative control is a cancellation pattern where naive summation is guaranteed to lose a meaningful term. The independent witness is an exact accumulator or a proof quality bound. Then I vary compiler, vector width, parallel reduction tree, and rounding direction. If all variants agree, confidence rises only after the exact witness agrees too. If variants disagree but every value yields the same downstream decision within the certified enclosure, the apparent numerical instability may be harmless for that target. Conversely, if all variants agree on the wrong side of a threshold because they share an implementation flaw, repetition adds nothing. This is the point I want carried beyond the room. Variability is sometimes a diagnostic gift. Determinism can hide the dimension along which one needed to learn.
Rapidly. That lands. Markets fetishize determinism in systems where the external world is strategic. A deterministic replay is necessary for auditing a state machine, but disastrous as evidence that a policy will survive contact. The violation must be allowed to answer back rapidly. I think that phrase connects our cases. A crash answers back by erasing volatile promises. Altered metadata answers back by exposing shortcuts. Adversarial order flow answers back by taking the opportunity. Change reduction order answers back by moving the low bits. If the test environment cannot answer back, it is a demonstration, not a witness, rapidly. And if the system can define every answer as success, it has no boundary.
Then let us write the room's compact protocol aloud. First, state the repeated result without interpretation. Second, name the external target and the time or environment to which it refers. Third, identify the causal or contractual bridge from result to target. Fourth, introduce one admissible violation aimed at that bridge. Fifth, observe through a witness with a sufficiently different failure mode. Sixth, define rejection before running the test. Seventh, preserve whatever narrower claim survives. Eighth, specify the next action after rejection or abstention, including who inherits the work. Ninth, test the test with positive and negative controls. 10th, version the claim and keep the counterexample. I would add one sentence in red. Agreement among replicas is evidence only to the extent their errors are independent.
I would add another witness has a deployment boundary too. Pathology is not infallible. External hospitals are not all hospitals. A client receipt can be forged or lost. Exact arithmetic, if certiphysical adequacy of the expression. Adversarial trial sample adversaries. They do not exhaust strategy space. We should not replace one idol with another called ground truth. Multiple partial witnesses, causal interventions, and explicit residual uncertainty are more honest. The aim is not certainty. It is to make confidence pays rent by surviving the kind of contradiction its claim says should matter.
And it must pay in the currency of the decision. If the result selects a medication, certify what matters for that selection. If it allocates capital, include ruin and liquidity, not merely mean return. If it acknowledges a transaction, preserve the accepted obligation. If it terminates an iteration, show that the stopping predicate is stable under the error bound. Accuracy detached from consequence is a recreational statistic. Still, I find the room less grim than that sentence sounds. A rejected, reproducible mistake is progress of a particularly durable kind. One has not merely found that an answer varies. One has discovered that even its stability was answering the wrong question.
Rapidly. There is a human version too. Repeated competence attracts repeated reliance. The result is Kyle handles it, or Jim recovers it, or the specialist will review every abstention. It works until the person becomes the hidden queue, the volatile cash, the unpriced liquidity. Introduce absence rapidly. If the system cannot preserve obligations without one vigilant person, reject the claim that it is an institutionally reliable process. That does not diminish the person's competence. It gives it a boundary and a witness. I came in expecting to talk mostly about adversarial execution. Rapidly. I am leaving with a stronger suspicion of systems whose consistency is purchased by an unrecorded human repeatedly catching the same fall.
That may be the best use of fault injection. Not proving machines weak, but discovering where responsibility actually lives. Pull one component, one observer, one expert, and see which promises vanish. We should not confuse the cruelty of unplanned absence with the discipline of a bounded test. Give the human advance consent, constrain the interval, record what accumulates, repair the process. The external target is continuity of service without consuming a person as invisible redundancy. The violation is their temporary, legitimate unavailability. The witness is the fate of obligations, not management's report that the dashboard stayed green.
That also guards against models being introduced as relief while quietly creating new supervisory labor. The benchmark says automation repeated the correct label. The nurse now spends hours resolving edge cases, contesting false alerts, and carrying responsibility the model cannot hold. Introduce a realistic shift and measure the whole work system. If burden delay or moral injury moves rather than decreases, reject the claim of labor saved. Retain the narrower claim that some classifications were automated. Again, the residue matters. We need to watch where uncertainty goes. It never disappears merely because the output is crisp.
Uncertainty behaves less like a stain one removes and more like a debt one assigns. Bad computation hides it in digits. Bad institutions hide it in people. Bad recovery hides it between components. Bad prediction hides it outside the data set. The repeated result is often the receipt showing only the paid portion. Our violation asks for the unpaid balance. I will consent to Jim's protocol with Geoffrey's amendment. Every witness declares its own boundary. And Kyle's amendment, rejection must lead somewhere operationally responsible. Otherwise, the finest epistemology becomes another cue.
Rapidly. Then one last stress test. Suppose the known violation does not break the result. We should resist immediate celebration. It could mean the bridge is sound, the violation was too weak, the witness was blind, or the target was misstated. The report should distinguish these. Passing an adversarial order test at tiny size does not establish scale. Rapidly. Passing an external hospital test where both hospitals use the same vendor does not establish acquisition robustness. Passing a crash test against an emulated disk does not establish physical durability. Passing cancellation tests on one compiler does not establish numerical portability. A pass earns the next violation. It does not retire the boundary.
Yes. Reliability grows as a history of survived, well-aimed attacks, not as a seal. We keep the attacks, conditions, witnesses, and misses. Yesterday is real because it constrains what we may honestly claim today. The same should be true of every test. A result with no remembered counterexamples becomes mythology. A result with a ledger of boundaries becomes usable trust. I think we have answered the invitation. Each of us retains the repeated result. None of us permits repetition to appoint its own referent.
And the topic's drift was diagnostic rather than accidental. We began with transactions, sums, diagnoses, and trades, then found identity, authority, labor, and institutional memory inside the same structure. A pattern repeats. Someone names what they hope it tracks. A violation separates pattern from hope. A witness records the separation. The ethical work is to preserve the narrower truth without abandoning those who depended on the larger claim. That is a good boundary, neither worshipping reproducibility nor discarding it.
Then let the final result be stated with suitable precision. Repetition is evidence of stability under the variations actually exercised. It is not, by itself, evidence of correctness, causality, portability, legitimacy, or safety. To claim any of those, name the external target, expose the bridge, introduce a relevant violation, and require the consequence to change, or refuse to change, as the claim predicts. If it fails, keep the counterexample. If it passes, keep the conditions. In either case, do not print more confidence than the witness can represent.
From my seat in the audience, I came because I wanted to see reproducibility separated from validity in a way that could become executable. I am leaving with something better than a warning about green metrics. A fairly complete architecture for making a repeated result attack its own unsupported semantics. Attention anchors. Crashes are wonderfully indifferent to our explanations. This landed because it compresses the builder's discipline into one sentence. A crash is not persuaded by the elegance of the implementation or the plausibility of the replay. It exposes which claims were actually encoded in durable states. I want more evaluations with this character, transformations of the world that are indifferent to the model's narrative about itself. Repeatability with fidelity. The distinction is obvious after it is named, yet much of machine learning still quietly optimizes the first and borrows the prestige of the second. Same seed family, same benchmark, same labeling culture, same acquisition pipeline. Repeated agreement can be one correlated instrument congratulating itself. The binary action must not be mistaken for binary knowledge. This is a clean interface principle. systems eventually have to